All right, 2.3, polynomial and syntactic division. We're going to start with long division, so I'll label it long division. So we're going to get 4x plus 5, and then what we put inside is 4x cubed minus 7x squared minus 11x plus 5. What times 4x gets us 4x cubed will be just x squared. 4x squared cubed. 5 times x squared is 5x squared. So we subtract, and negative 7 minus 5 is negative 12 x squared. Bring down to negative 11x, and then what times 4x will get us negative 12x squared? That'll be negative 3x. That's negative 12x squared minus 15x. Subtract, we'll get 4x. Bring down to 5. What times 4x gets us 4x? That's just 1. We're going to multiply, get 4x plus 5, subtract it, no remainder. Hooray! So therefore, your solution is going to be what's going to be in this box. X squared minus 3x plus 1. This is what's called the division algorithm. This is kind of a guide to how we should write our answers, right? Because if we have this, the dividend, or in the case of that first problem we did together, your dividend would be 4x cubed minus 7x squared minus 11x plus 5. That would be your dividend, okay? And then dx would be what we call our divisor, the number you're dividing by. In our first example, that would be 4x plus 5. Your solution to this will be your quotient. Once again, divisor. And this is your remainder. Meaning, we wrote it just fine in our answer on our first problem because we just had a quotient. We didn't have a remainder. If we do get a remainder, we take our quotient and then do a plus whatever our remainder is. If it's 5, it's 5. If it's x, whatever it may be. Remainder goes here, divisor goes here. So whatever so it would be your quotient plus whatever your remainder is divided by your divisor. That's how you would write it. All right, new problem. X cubed minus 9 divided by x squared plus 1. So I know I wrote it like this, but I'm going to make a little change. Anytime we skip values in our dividend, we're going to put a 0 there as a placeholder. This will help us, okay? Whenever we're adding, subtracting, whatever. So what times x squared gets you x cubed? It's x. Multiply it out. X cubed. X times 1 is x. I'll put it under the x to help us out. Subtract 0 minus 1 is negative 1. Negative 1x minus 9. And we can't do anything more. Oh boy. So your solution is going to be x plus negative x minus 9 over x squared plus 1. There we go. That's our solution and how we should write it. So next we're going to divide using synthetic division. Synthetic division. Okay, so how that works is in this little box, it's whatever value makes this 0. Okay, what makes it 0? It's 6. And then what's next is I'm going to put all of the coefficients of our dividend right here. Now be careful, because if you skip any, meaning if you go from x cubed to x all of a sudden, you need to put a 0 down. Like in this case, I go from x squared to a constant, so I'm going to put down 0 before I put negative 72 down. Bring down the first term straight down. 3 times 6 is 18. Add it, you get 2. 6 times 2 is 12. Add it, you get 12. 6 times 12 is 72. Add it, you get 0. Now what does this mean for us? If you work right to left, we have a remainder, then your constants next, then your x squared. So your solution is going to be 3x squared plus 2x plus 12. There we go. Let's do another syntactic division problem. So in this case, what's in the box, once again, is 6, ironically. I'm sorry, people say divisor in both of them. But then we got -1 for the coefficient of x to the 4th. There's no x cubed or x squared, so I'm going to put zeros there, and then I'm going to put 180 and 0 down. 180 is the coefficient for x. There's no constant, so we're going to get 0. Bring it straight down, you get -1. Multiply, get -6. Add, you get -6. Multiply, get -36. Add, you get -36. -36 times 6 is going to be -180. Add it, you get 0. 0 times 6 is 0. Add, you get 0. So what does this mean? 0 is a remainder, 0 is a constant, -36x minus 6x squared minus x to the 3rd. Here's our solution. So I'm going to kind of kill two birds with one stone here and do the remainder and factor theorem together. When we divide a polynomial by x minus k, this part's the remainder theorem. We're dividing by x minus k. The remainder will always be equal to f of k, meaning if we just plug in whatever this value is right here, remember its original is x minus k, just plug k into the function, whatever your output is, that's the remainder. Similarly, with the factor theorem, whenever we do put in that k value in, this is the factor theorem part, not x. We put the k value in everywhere. If your output is 0, that means x minus k is in fact a factor. Then x minus k is a factor. We will try a couple just to test it out. So in this case, we have the polynomial f of x is equal to 2x cubed minus 7x plus 3. Well, I want to see if x minus 1 is a factor or x plus 2 is a factor. It could be both of them, could be none of them, I don't know. We'll see. So the k value in the first one is 1, right? So I'm going to be plugging in 1 everywhere into this function. Giving me 2 minus 7 plus 3, which is -2, so it is not a factor. Not a factor. And if we were to divide them, we get a remainder of -2. Now for the other one, let's try it out. So we put -2 everywhere. Now get us 2 times -8 plus 14 plus 3. Give us -16 plus 14 plus 3, which is 1. Still not a factor. Okay, we need 0 for it to be a factor. -2 and 1 won't work. Those are the remainders, but remainder needs to be 0 in order for it to be a factor. So I'm giving you this polynomial function and 2 of the factors. I want you to find the other 2 factors and list all the zeros. So it's pretty hard to do because we can't factor it, right? But we can do is we're going to do syntactic division twice. Okay, so we're going to put that k value, one of them. You could have started with -4 if you wanted to, but I'm going to put 5 in. Then all the coefficients right here. Okay, bring the 1 down. 1 times 5 is 5. Add it, you get 1. 1 times 5 is 5. Add it, you get -10. Multiply it again, you get -50. Add it, you get 8. 8 times 5 is 40. Add it, you get 0. So what I'm going to do, well, first off, we need to check to make sure it's a factor, and it is, because luckily we got a remainder of 0 right here, which is good. So I'm going to take these numbers here and do it one more time with that other factor, in this case -4. 1, 1, -10, 8. Bring down the 1. 1 times -4 is -4. Add, you get -3. Multiply again, you get 12. Add, you get 2. 2 times -4 is -8. Add, you get 0. So what I have left, x squared minus 3x plus 2. Let's find the other factors. If you factor that, it's going to be x minus 2 times x minus 1. So your complete factorization, if I ask you for that, complete factorization is this and this. That's complete factorization of this problem. What will your zeros be? What will your zeros be? Zeros will be 2, 1, 5, -4. And those will be your solutions. Appreciate you watching, and we'll see you in class.